Welcome students. In the previous class we studied about the polynomials, the degree of polynomial, the number of terms, what are the coefficients, all these things we learned about polynomial, and we knew that polynomial is an algebraic expression in which the variable always carry an exponent which is always non-negative integer. Now in this session we will study about the zeros of polynomial. What do you mean by zeros of polynomial? To know this we have to discuss some other things. Let's see. To find the value of polynomial for a given value of the variable, we have to learn this. Next, to find the value of the variable for which the value of the polynomial is 0. Now let's see what is this. You see, this is a machine in which we put something, some process is going on inside it, and after that some output is coming out. The evaluation of a polynomial is just like a machine. If we put the value of x, then in the polynomial the calculations are done, that is the process, and after that we will get a final value which is called the value of the polynomial px. Now let's see how to do it. Here a polynomial is given. Px is equal to 2x square minus 5x plus 1. As discussed before, we have to put some value of x, then we have to do some calculations, that is under process, and after that we will get a result that comes under value of px. Let's look at x equal to 1. If we put x equal to 1, what can you say? Here px is equal to 2x square minus 5x plus 1. If we put x is equal to 1, we can write this as p1. So for that we can say what we here we have done, that replacement of x as 1. So here in right side also we have to replace x by 1. So here it is 1 square minus 5 into 1 plus 1. What is it? 2 into 1 square. Here it is 2 minus 5 into 1 minus 5 plus 1. So what is the result? 2 minus 5 minus 3 plus 1 minus 2. So see, in this table we have also done this same thing. So the result is p1 is equal to minus 2. Let's take the value of x as minus 1. Then what happens? See, 2 into minus 1 square minus 5 into minus 1 plus 1. What is the value now? You see here, in place of 1, if we replace 1 by minus 1, that means value of x taken as minus 1. Minus 1 square is 1. 1 into 2 is 2. Then minus 5 into minus 1 is plus 5 plus 1. So 2 plus 5, 7 plus 1. So this becomes 8. So for value of x as minus 1, the value of the polynomial is 8. Now what is the value of polynomial for x is equal to 2? Just replace the same thing. Then how to write the polynomial here? The polynomial here is written as P2. So 2 into, in place of x we can write 2 square minus 5 into 2 plus 1. So 2 into 2 square is 8 minus 5 into 2 is 10 plus 1, that is minus 1. You see here minus 1. Value of polynomial for x equal to 2 is minus 1. Similarly, for x is equal to 0, 2 into 0 will be 0, 5 into 0 is 0, and the rest is 1. So P0 is 1. So in all these cases, we can find the value of the polynomial for different values of x. Now see, evaluate this polynomial at two different points, that is for different values of t. Qt here it is written. Here I can say that we not only use always px, but we can also some other letters to represent the polynomial. Here as it is written, Qt is equal to t to the power 4 minus t to the power 3 plus t square minus t plus 1. Here this is a polynomial in t. Now how to evaluate? See, for q is equal to 1, what to do? In place of t, just replace 1. So t to the power 4, here it is 1 to the power 4. Minus t to the power 3, here it is minus 1 to the power 3. Plus t square, here it is plus 1 square. And minus t, here it is minus 1. And plus 1 is there, so 1 is also there. Now you know the power of 1 is always 1 whatever be its exponent. So in all these cases we have the value 1. So this is simply 1 minus 1 plus 1 minus 1 plus 1. So 1 minus 1 and 1 minus 1 cancelled out, and the result is 1. So Q1 is 1 here. Now what next? We have to find the value of t at minus 1. Value of polynomial at t equal to minus 1. So replace t by minus 1. What do you see? Minus 1 to the power 4 minus 1 to the power 3 plus minus 1 square minus 1 plus 1. As the power of minus 1 is even, its value is 1, and if the power of minus 1 is odd, its value is minus 1. So just calculate. The first term is 1, the second term is minus 1. So minus of minus 1, you see, minus 1 to the power 4 minus 1 to the power 3 plus minus 1 to the power 2 minus 1 plus 1. Here the value is plus 1. Here minus of, here the value is minus 1. And in this case plus minus 1 whole square, this is plus 1. This is minus of minus 1 plus 1. Now here it is minus of minus 1 is plus 1 plus 1 Here again minus of minus 1, that is plus 1, plus 1. So sum is 5. Let's see another example. The example is ry is equal to 5y to the power 3 minus 3y square plus 4y plus 1 at y is equal to minus 1 and y equal to 0. We have to evaluate this polynomial. Now you see here the polynomial is expressed as ry. That means we can use r also to denote a polynomial as we used qx and px. Now you see for the value of y minus 1, what will be the value of the polynomial ry. Now you see at y equal to minus 1, we can write r minus 1. So this becomes, just we have to replace minus 1 in place of y. So 5 minus 1 to the power 3 minus 3 into minus 1 to the power 2 plus 4 into minus 1 plus 1. And as we know, the odd exponent of minus 1 is gives value minus 1. So 5 into minus 1 minus 3 into, and minus 1 square is plus 1 plus 4 into minus 1 plus 1. So 5 into minus 1 is minus 5, minus 3 into 1 is minus 3, plus 4 into minus 1 is minus 4 plus 1. So minus 3 minus 5 minus 8, minus 8 minus 4 minus 12, minus 12 plus 1 gives minus 11. So value of this polynomial at minus 1 is minus 11. Let's see, let's evaluate it for the value of y at 0, r0. For r0, you see all the y terms except the constant term 1, all other become 0. So the value will be 1. Now let's see a polynomial px which is x minus 1 at x equal to 1. So again you see we can write this as p1. In place of x, if we write 1, so this becomes 1 minus 1, which is 0. So here for x is equal to 1, the value of polynomial is 0. So we can call that 1 is the 0 of polynomial px. 1 is also, if we look at this, x minus 1 equal to 0. If we evaluate this, if we solve this, what will be the value of x? The value of x is 1. So 1 is called 0 of polynomial px, and it is also root of the equation x minus 1 equal to 0. And what is x minus 1? X minus 1 is the polynomial px. So we can say that 1 is root of the equation px equal to 0. Now see another example. Here evaluate qx is equal to x plus 2 at x equal to 2 and x equal to minus 2. If we put the value of x as 2, what happens? It becomes 2 plus 2, that is 4. But if we put the value of x as minus 2, then what happens? It becomes minus 2 plus 2. Its value becomes 0. Now you can say, what is minus 2? What can we call about minus 2? As the value of qx becomes 0 for the value of x as minus 2, we can say that minus 2 is the 0 of the polynomial qx. But at 2 it is not 0, so it is not 0 of polynomial. So 2 is not the 0 of polynomial, but minus 2 is 0 of this polynomial. Again, if we see, then minus 2 is also root of the equation x plus 2. What is x plus 2? X plus 2 is our polynomial. So we can say that minus 2 is the root of equation qx is equal to 0. Our equation is qx is equal to 0. Now, the 0 of polynomial px is the root of the equation px equal to 0. As from these two examples, we conclude how to find the 0 of the given polynomial. Then this is the simple way. If we solve the equation px equal to 0, whatever the value we get, that of x is the 0 of that polynomial. Now, find the 0 of polynomial px is equal to 2x plus 3. In last two examples, the questions were very simple and it based on integers, and it was very easy to find out the 0 of the polynomials by substituting some integers. But in this case, it is not possible. But we have given a clue before this line that the 0 of the polynomial px is the root of the equation px equal to 0. So to find out the 0 of the polynomial px equal to 2x plus 3, we have to find the root of the equation 2x plus 3 is equal to 0. Now let's solve it. 2x plus 3 is equal to 0. This implies 2x is equal to minus 3. Now what is x? X is equal to minus 3 by 2. So as this is the root of the polynomial, the equation 2x plus 3 equal to 0, so this is also the 0 of the polynomial px. So x equal to minus 3 by 2 is 0 of polynomial px. Let's check it or verify it whether x equal to minus 3 by 2 is polynomial of 2x is 0 of 2x plus 3 or not. As 2x plus 3 is our polynomial, find the value at minus 3 by 2. So 2 into minus 3 by 2 plus 3. Here you see 2 and 2 cancelled. What do we get? We get minus 3 plus 3. This is equal to 0. Clearly we see that minus 3 by 2 is the 0 of the given polynomial. Now, as earlier we discussed the example, all the examples are of the polynomial of degree 1. So in this case, the general form of the polynomial of degree 1 is ax plus b. Then how to find the 0 of the polynomial? We know the equation, if you solve the equation x plus b equal to 0, then we can find the 0 of this polynomial, and this gives x is equal to minus b by a. Is there any other value of x for which this ax plus b will become 0? No, as this is a linear polynomial, it has one and only one 0 possible. So every linear polynomial has one and only one 0. Now let's take a constant polynomial. Here px is equal to 5. Can you find the 0 of this polynomial? If you put the value, whatever you put the value will always be 5. It can never be 0. So we can say the 0 degree polynomial or constant polynomials cannot have any 0. So we can write a constant monomial has no zeros. Now take another example. Find the zeros of polynomial px is equal to x square minus 3x. As you see, all the terms contains x. If we put the value of x as 0, each term will become 0. So we can say that p0 is a 0 of the polynomial. But what about the other polynomial, other 0, if any? Now here it is written p3 equal to 0. Is it true? Is polynomial, the value of polynomial 0 at 3? Let's see. Px is equal to x square minus 3x. So p3 is equal to 3 square minus 3 into 3. So this is 9 minus 9, 0. So the value of the polynomial is also 0 at x is equal to 3. So here we have two zeros of the polynomial. Now see, this is a quadratic polynomial. We have two zeros, and we know that as the polynomial is of degree 2 and is called quadratic polynomial, it has two roots. Now take another example of quadratic equation, x square minus 4. Here x square minus 4 equal to 0, as we know that if we solve the equation, then we get the 0. If we solve the equation px equal to 0, then we can get the 0 of the polynomial. Here the px is x square minus 4. So let px equal to 0 or x square minus 4 equal to 0. This gives x square is equal to 4. So for which values of x, its square is 4. This shows x is 2 or x is minus 2. Now when we solve it, we get the roots of this equation are 2 and minus 2. Now if you replace this, you can also verify this by taking the value of x as 2. This becomes 2 square minus 4, that is 4 minus 4 equal to 0. And if we take p minus 2, here also we have minus 2 square minus 4, that is 4 minus 4. Square of minus 2 is 4, so 4 minus 4 equal to 0. This clearly shows that this polynomial x square minus 4 has two real roots. two real zeros, and the equation x square minus 4 equal to 0 has two equal roots. So we can say that by taking two examples, we saw that a quadratic polynomial has two zeros. Is it always true? Let's see another quadratic polynomial. In this case, the constant term is 2 and degree of polynomial is 2. As earlier we know, if the degree of polynomial is 2, we can have two zeros. So we expect here two zeros. We can try two numbers whose product is 2. As we know, the product of two number is 2. One is 2, another is 1, or one is minus 2 and another is minus 1. Product of these two is 1. The product of these two is 2 and product of these two is also 2. Now let's try with 1. P1 becomes 1 square minus 3 into 1 plus 2, that gives 0. So 1 is a 0 of this polynomial. Now see, if 1 gives the 0, then we have to try with 2. So 2 square minus 3 into 2 plus 2, this gives 4 minus 6 plus 2, that gives 0. Clearly it shows that this polynomial has two zeros. One is 1 and the second one is 2. So from all these discussions, we conclude that a 0 of a polynomial need not be 0, and 0 of polynomial can also be 0, as we saw. Every linear polynomial has one and only one 0, and a polynomial can have more than one zeros. As in case of quadratic polynomial, we saw two zeros, and a constant monomial has no zeros. Now let's see some quick look at the examples. Find the value of px where px is equal to root 2x square minus x at x equal to 2. Root 2 into x square, so p2 is equal to root 2 into 2 square minus 2, that gives 4 root 2 minus 2. Next, another example, another question. Evaluate the value of px equal to 2x minus 7 for which it is 0. As we know, px is equal to 2x minus 7, and for which value it is 0 means to find the 0 of this polynomial, and to find the 0 of this polynomial we have to solve the equation 2x minus 7 is equal to 0. This gives 2x is equal to 7 and x is equal to 7 by 2. So 7 by 2, the value of x is 7 by 2, for which px is equal to 2x minus 7 is 0. Now students, we learnt about how to find the value of polynomial at different points, means for different values of the variable. And also we learnt how to find the zeros of the polynomial. Now this is the time to leave. Thank you.